The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. This is John Jensen from SMC. I'll be your host and presenter today. The topic for today is pneumatic system troubleshooting. A couple of housekeeping matters. If you have questions as we're going along, there should be a place on your webinar screen to type in questions, and we'll tackle those probably at the end, or maybe I'll take a glance at it here and there as we go along and see what we can cover. Feel free to use the chat window as well for communication. But if there's specific questions, go ahead and do that. So this topic came out of a couple of requests. Several of our customers, particularly those with large compressed air systems and large facilities, have been shut down or on limited production schedules. And we have had, myself and a couple of other folks have had questions about, well, when we go to start back up, what do we need to look for and how do we do that? So what we decided, a colleague of mine and we looked at some materials that we had for troubleshooting, and we thought it was a good idea to review troubleshooting just on the expectation that when we go to start machines up that have been sitting idle for a bit, it's probably not going to go well. So I thought a review of the troubleshooting at a high level would be helpful. And also then at the end of the presentation, we've started to put together a list of other considerations that you might have when restarting a large pneumatic system. So let's get started then. Pneumatic system troubleshooting, we'll take a look at that first. And in any discussion of troubleshooting, we certainly want to talk about safety. Now, some of this content assumes that you may be tackling an unfamiliar machine or new to the facility. But in any case, we always have to be concerned about safety. We know that pneumatic system components can be a hazard, as well as any other mechanical components. We want to make sure that we're aware of everything, the equipment, that we're comfortable with the equipment we're looking at, and the personnel we'll be dealing with. And this is especially true if we're being called in as an outside troubleshooter. One of the first things to take a look at is take a look at the warning signs, right? Most machines have warning labels like caution, warning, or danger. Look at those placards if you can, and also be sure that you're familiar with the procedures, particularly lockout, tagout, and other things like that. Take a look here. I'm getting a little bit of background noise. Can I mute all? I think I can do that. Okay, so moving on. The next thing to consider, any safety procedures. So safety glasses, proper footwear and clothing, proper hearing protection. If you're a visitor to a facility, take a look at any required safety videos and also any additional requirements. In the heat of the moment, if you're trying to get a machine started and things are not going well, it's tempting to sidestep the safety protocols. I don't need my glasses just now, or don't bother put the hearing protection in, or don't bother to put my gloves on, or I'll just reach in here with a stick or a wrench or what have you. So don't be tempted to shortcut or sidestep any safety protocols. Even if you're in a hurry, you always need to be safe. So that we'll make that a priority for sure. So once you've decided that something needs fixing, what do we do next? Well, certainly the lockout procedures are important. So any lockout tagout procedures, and then verify before proceeding. We never assume that equipment is safe. Even if you've opened a door and heard the air hiss and the system appears to be vented, don't assume that that's all the pressure there is. Double check and verify. So we want to verify that electric power has been removed and that stored energy is vented or isolated. And you may have to do some digging here. Many times the lockout tagout might vent the machine except for a small tank full of air, or a cylinder with a pilot-operated check valve. So there may be, or there should be, written procedures for once the lockout tagout has been applied. These are the steps to remove the rest of the stored pneumatic energy in the machine. So let's make sure that that's true. Compressed air has been safely removed. Double check if there are air reservoirs. Those are certainly things to check. Look for check valves. Look for any kind of stored pneumatic energy. Presses, of course, are things with not only pneumatic energy, but weight due to gravity need to be blocked or pinned in a safe state. So, and that's true of any other mechanical items on the equipment. It all has to be secured. Look for overhead or suspended loads, especially if loads are suspended by trap pressure. Pilot-operated check valves, holding a gripper closed or a clamping mechanism. Close center valves, of course, need to be checked if they are holding a load, and it's especially true. Well, all pneumatic components might be prone to leakage, so pilot-operated check valves might not hold a load indefinitely. Close center valves certainly won't. So if you're relying on a close center valve to hold something overhead, be assured that that's not going to last forever. There will be enough leakage over time that something could fall unexpectedly. So to review that, when you're safely shutting down a machine in preparation to look at it and to troubleshoot it, the procedures are to secure the suspended loads, exhaust all of the air pressure, drain the accumulators, discharge any intensifiers, isolate electrical controls, isolate power supplies, and also give a care to things other than pneumatic energy, like electrical, hydraulic, and mechanical, high pressure or high current devices, for example, resistance welding machines, high pressure hydraulic presses. Those will require extra care. So make sure that you have taken everything into account. I mentioned resistance welding transformers. That's certainly a concern, and there may be other things that we should be specifically on the lookout for. I've mentioned some of them, but just to review here, pneumatic actuators and directional control valves can have trapped air. Ideally, you'll have a schematic, and you can take a look at that schematic and see where the trapped pressure will be and take steps to eliminate that before making other additional contact with the machine. And this is probably an older figure, but 120 people each year are killed by industrial machinery, approximately. So be careful. Make sure that the safety protocols are observed. Loose clothing that might get caught in a moving part should be dealt with. Any of those kinds of things. Overhead loads, of course, that I mentioned, any production parts still in the machine that have the potential to fall, all of those things can be a safety concern, so pay particular care to those 3 points. Then, now, finally, we've done a lot of work here and we haven't even begun to troubleshoot, and this is now where it starts. We want to make sure that when we enter the machine that the access gate actually does vent the pressure and that it locks out the machine's PLC or other type of control. You want to make sure that there's no possibility for any automatic operation of the equipment. Also double check that manual operation isn't possible, or if it is, be very careful. For example, pressing a manual override on a valve. You want to make, if you do that, you want to make sure that everything is clear. I know I years ago got yelled at by a maintenance tech. I pressed a manual override on the valve, and about 40 feet away, he was looking at something, and the cylinder moved, and he wasn't close enough to be hurt, but he was a little scared, and the language he used was even scarier. So be careful about those kinds of things as well. Manual overrides can be troublesome, especially if there are other people assisting you. Here's a point to mention that follow the OSHA lockout tagout procedure. It may be, there's protocols for those. The troubleshooter might be asked to have their own padlock with a personal identification. Typically, your padlock has to have your name and your picture on it so that all personnel can lock the work cell, and every person will have a padlock so that Anyone entering the work cell is accounted for, and the gate could not be closed and the machine's production could not be started until everyone is safely out of the work cell. So that lockout tagout is important. Also, something to note here is where the lockout tagout is. If it's in full view of all the moving parts of the machine, that's certainly easier and safer. If the lockout device is such that it's possible for the last person to remove their tag and not have noticed that someone else stepped into the danger zone. So you want to make sure that you're considering those sorts of scenarios as well, that if someone is, if there's any chance that someone could have entered the machine while you were occupied with a lock, you want to make sure that before anything's started up that there's a final check that's done. And this is, of course, even more important if you're a visiting troubleshooter, visiting a plant and you're unfamiliar with the protocols, unfamiliar with the machines, unfamiliar with the processes and procedures. So be alert, be careful, and don't assume anything. So troubleshooting, obviously still talking about safety. Pneumatic systems are dangerous. Investigate with great care. And until we've identified the stoppage, stay clear of any work areas. We certainly wouldn't want to be in a situation where we're standing, where something is blocked or something that should have moved is not moving and we are standing in front of it, because we don't know if something might unexpectedly move, if a jam might clear itself unexpectedly, if there's still trapped pressure trying to cause a movement. And so be very, very cautious there. So obviously we can't foresee every possible scenario. So generally, you want to make sure that we ask questions, that we get help, we talk to people who are familiar with the particular piece of equipment, and make sure that we know someone or someone is helping us who is very familiar with what normally should happen. And that will also aid in identifying the cause of failure as well as preventing any injury due to unexpected motion. So troubleshooting probably is one of those processes that if we've been doing it a while, we take some shortcuts. But the best thing to do is to be methodical, right? If you remember the scientific method, back in grade school or junior high, there's no troubleshooting problem that could stand up to the scientific method. If you make a hypothesis, test it, and test them one at a time, and then move on to the next. That can be, you'll always get to the end. You'll get the machine running. Now, obviously, we tend to take some shortcuts in that, but what I'm going to outline here is a more methodical process and one that's surefire, right? So that when you have taken some shortcuts and the machine still won't run, you can go back and go back again. So some of the things to be aware of: first of all, what do we check? What are the measurables that could help us identify the problem? What do I check with? Is there any special equipment or instruments that might be needed? Where would I check? Where in the pneumatic system would I carry out the checks, and what should be done first? And what do I expect? If I'm taking a measurement, a pressure measurement, for example, it's useful to know what the correct reading should be, right, in order to draw some conclusions. So those are some of the things you want to take a look at. For example, what to check. A pneumatic system is a way of transmitting power, right? It's a power transmission system. So if we consider a pneumatic actuator as a device to convert pneumatic power to mechanical, the force generated is governed by the pressure. The velocity is governed by the flow rate. And so I'm sure we're all veterans here that realize that flow and pressure are not the same, but if you ever have any assistants or people helping you, you may want them to repeat that. Flow and pressure are not the same, and repeat that until it's clear, right? So we want to make sure that the problem we've identified is that we know what to look for. If the issue is a speed issue, that's controlled by flow rate, or maybe might be affected by friction. If it's which again could be indirectly related to pressure. If it's a force issue, then it's definitely pressure. So flow and pressure and direction of movement, those are the things we want to take a look at. So when we check, often you'll hear someone say, well, it doesn't have enough power. Well, power is a little bit unspecific, so we want to make sure that we've asked some more clarifying questions. Do you say it's lacking power? Does that mean the actuator is moving too slowly, or it's not providing the required force? So once we've defined the problem, is it speed, force, or torque, or direction, then is the problem flow, pressure, or direction? And that will give us an idea of what to measure. Some other things that we might end up measuring, if we might be dealing with negative pressure or vacuum, we might be dealing with temperature. If we're looking at a hydraulic system, a high temperature might indicate excessive flow. With a pneumatic system, due to adiabatic expansion, excessive flow might have a cooling effect. You might see frost on a silencer, or you may see a bit of frost or cooling on a piece of tubing on its way in and out of a high-speed actuator. Noise, of course, might be an indicator, and that's something you ask someone familiar with the machine. Does it always sound like that? Is it supposed to make that noise? Those can be good indicators of a problem, and certainly maybe not a critical problem, but if there's a chronic problem, contamination issues might be something to be checked. The cleanliness of the air or cleanliness of the fluid could certainly be a cause of repeated failures. So the things that we're measuring then, we might need pressure gauges to measure pressure. We might need a flow meter to measure flow. We may need a vacuum gauge for pressure below atmospheric. We may need to send a sample of compressed air out to test for contamination. There may be various things that we might need to do. So we may need some somewhat specialized equipment to make our checks. So things that are useful: pressure transducers and potentially a data logger or recorder. That can be very helpful on a machine if you can identify pressure in the few locations and then record it as the machine moves. That might tell you if there's excessive pressure drop somewhere, or excessive pressure peaks, transient pressure spikes, things of that nature. A flow meter might be used to get a baseline reading when the equipment is functioning normally, and then checking periodically can indicate increased wear. An excessive flow can indicate an increase in leakage. And I'll mention here as an aside, I would hold that almost any pneumatic failure could be predicted by leakage. A cylinder that stops moving has got to have been leaking over the piston seals or the rod seals or both for a significant period of time before it actually quits. So leakage is a very good indicator as to what the health of a machine. Temperature gauges might be useful. A troubleshooter might carry a non-contact infrared thermometer with them. That would be helpful. Noise meter, you might be listening for noise. And on a related note, you might use an ultrasonic device to detect air leakage. That can also be helpful in pinpointing a leak if it's a noisy place and you're not able to identify a large leak. Particle counter might be helpful as well. Now in pneumatic systems, I don't know too many people who have their own particle counter, but there are any number of laboratories that can take a compressed air sample or have you run some air past a filter for a predetermined amount of time and then send that filter in for analysis to see if contamination of some kind is the cause for repeated failures. So the measuring instruments, particulate contamination, a point of use air filter or a lab test could be useful. A pressure gauge for measuring pressure, a flow switch or flow meter, and there are several kinds of those. Noise with a decibel meter, temperature can be used, and making some kind of chart recorder showing a data logger box here and this is an 8-channel one that we happen to use, but there are also single channel type data recorders that are very inexpensive and can be very helpful if you need to get to the cause of a problem. Just a couple of notes. If you're checking pressures, you know, this is obviously there are different kinds of pressure gauges. The gauges you see on machines may have a board and tube type of gauge. They may have some kind of a snubber arrangement. I think anymore we're seeing more digital pressure switches on machines, and the little handheld pressure switch or pressure gauge that we have, the compact manometer down in the bottom right, that's a troubleshooter's friend. I mean, that's kind of the equivalent to the electrician's multimeter, right? That little device can measure pressure. You can clear its memory and it will record the peak and bottom pressures for as long as you've left it pressurized. So that can give you an idea. And if you expect that a pressure drop, some random pressure drop is causing the machine to fault, this might be a way to tell you, did that actually happen? The minimum pressure recorded was, 6 psi. That might tell you there's an issue. Or the maximum pressure recorded. Now, it doesn't tell you when that event happened, but it would tell you, it would be the first step in determining whether more pressure measurements and perhaps a data recorder would be warranted. And you can check with permanently installed gauges. Some systems may have a little isolation valve that you have to press a button to read the gauge. There may be a shutoff valve or a test port that you can use, or there may be just random fittings or tees that you can use to install a pressure switch and get a reading. As I said, you might see a gauge plugged into a port. If you suspect that the gauge that is installed may not be accurate, you may be able to remove an existing gauge and use a new digital gauge that is more accurate or has been recently tested. If you're lucky, the system has test ports or test points that you can use without too much trouble. Checking flow might be another issue. There are several kinds of flow meters. There are float type ones or turbine types. There are also any number of digital flow meters nowadays. I would say this second point here, flow meters are rarely connected into a system permanently. And that's still somewhat true, but I think the trend and the recommendation is every machine should have a flow meter. Not only as part of an energy conservation program by alerting the need for maintenance to repair leaks, but also just as a means of judging the health of the machine. As I mentioned, almost every failure can be predicted by the leakage rate. So a machine that has no leaks is very likely running the same way it did when it was new. A machine that has 10 or 20 CFM worth of leakage built in is certainly not going to be performing the way it did before. It might still be doing its job, but certainly inefficiently and probably not as quickly or with the same minimal scrap rate it had before. So when you're checking flow, however, be careful as to where you're checking. You might look at the photo here. This is just showing a temporary installation of a flow meter and a pressure switch that was temporarily installed to do some troubleshooting to get an idea what the machine was doing. Now, in this case, we used a chart recorder or data logger to identify the flow spikes and corresponding pressure drops, as well as measure the leakage rate when the machine was offline. And ideally, yes, the offline flow is typically leakage. That would be great if it was less than 10% of the flow when the machine was running. I think the reality is that number is often much higher. So once we've got all of our tools and everything is ready, we want to record observations, right? I know it's tedious, but let's get some good information and let's write it down. What's happened? When did it happen? Where did it happen? For example, we want to, rather than saying the machine is broken, a better description might be the directional control valve is not shifting. The double acting cylinder that opens the slide gate is not retracting. The machine sequence stops after mechanical limit valve 6 has been actuated. And then some additional. When did it happen? Was this a sudden failure? Is it gradual? Was there anything that predicted it? Or is it intermittent? Intermittent's, of course, the worst. It never happens when you're watching it, right? and have any changes been made, right? Has someone made a change to the machine? Has someone made an adjustment to pressure or flow, pressure controls or flow controls? And it may have happened and people don't want to confess. Maybe they don't want to get in trouble for having broken the machine. And we're all quick to point out, right, that when something happens, well, you touched it last, right? That can also be true if you're the troubleshooter. If it ends up being worse after you looked at it, then you're certainly going to get the blame for it. And also, people may not even know that that the change they made was relevant, and so they may not confess for that reason. Like, well, all I did was replace that directional control valve. Well, maybe that's the problem. Did the problem start in conjunction with any facility changes? Were there changes to power? Were there changes to compressed air sources? Any other issues that might have been unrelated? I've had this happen where a compressor has broken down in the compressor room and a rented compressor is brought in, which can have some issues. There may be more or less pressure than there was before. The rented compressor may not have any filtration and potentially was connected after the plant's filtration system. Was there air quality? There been any water in these air lines? Has the dryer broken down? Have we set any filters in bypass? Any of those kinds of things that may be facility issues that could have an effect. And you may need to ask more people about that. You know, the machine operator may be unaware of changes to the facility or to the main system. Other specific questions to ask would be, where does the problem occur? Does it happen when the machine is starting up? Or does it happen after the system or component has been running for a while? Potentially a buildup of heat or buildup of friction over time, or maybe it's a cold start problem. A valve not shifting because it's sticky, or something of that nature. Something else that might help you, if there are good maintenance records. If this problem has happened before, perhaps we have a record of it. Ideally, someone solved the problem, wrote down the solution, and if we can take a look at those records, oh yeah, even if the person who fixed it last time isn't available, if they had good records, and we can, that may shorten the time very, very quickly. And of course, a visual inspection. We can look for basic things like worn tubing, broken fittings, physical damage like broken gauges or smashed connectors on solenoids. Obvious things are the first place to start. Obvious issues like leaks, kinks, physical damage, so on and so forth. And if you're, again, unfamiliar with the machine, ask some questions. Ask as many questions as you can before you just start pushing buttons and trying to make repairs. And taking some notes is always a good process at this point. Ideally, we would also be able to consult a schematic. That will explain the function of the components and can be very, very helpful as a diagnostic tool. It might tell you where there are test points for pressure. It might tell you what the correct pressure settings of regulators would be. It might tell you flow rates. And perhaps if it's a more modern machine, maybe it will tell you the setting of the flow control with the dial indicator. You know, what those should be set at. It might give you cylinder stroke lengths, cylinder speeds, air motor speeds, positions of valves at rest, the bill of materials, and the bill of materials should not be overlooked. I've had a couple of instances where a troubleshooter replaced a directional control valve and found one that looked the same, but it ended up that it was a 110 volt valve coil that was installed on a 24 volt DC machine. The odd part of that is that the indicator lights still would light up, but the valve wouldn't shift. So the bill of materials would tell you the correct part number for that valve that had been replaced. And in that instance, you know, the original troubleshooter was not going to confess that they had changed out a valve the night before. So any of those things, all of that data can be very helpful to determine if the system is working the way it was designed and if it still has the components it was designed to have. There may be a maintenance manual or a troubleshooting guide that came from the OEM, the system manufacturer. That also might include some service bulletins. Maybe there has been an update, or maybe an obsolete component has been replaced with something else, or the suggested replacement would be noted. So take a look at the paperwork if you have access to that. And then, of course, let's operate the machine and watch what happens. And with any luck, the malfunction will occur while you're standing there watching it, rather than be one of those pesky intermittent problems. Do some visual inspection as the system operates. Note if there's any excessive leakage. Are the gauges at levels specified? Are pressure gauges holding steady, or are they bouncing around? Do any controls feel loose or stiff? Are actuators moving smoothly, or are there erratic motions? Is there the stick slip phenomena happening on pneumatic cylinders? Maybe if you're lucky, the abnormalities will be obvious and this troubleshooting time will be shorter. If it's not obvious, then you may have to start going step by step, isolating subsystems to determine if the malfunction in one part of the machine was caused by some other subsystem on the machine. It's possible that a low force or low pressure could have been caused by even an adjacent machine or some other event in the facility. So isolating the investigation down to the subsystem with the malfunction lets you get eventually down to the component level. If we get to the bottom there and we have determined the component, and maybe we've found that this actuator is too slow. Now, we still don't know the root cause there. Could it be the lubrication issue? Could it be contamination? Could it be excessive lubrication due to a broken lubricator? Could it be partial shifting of the directional control valve? Could it be the seals on the piston? Could it be rod seals? And any of those things would need to be identified so that the root cause can be addressed as well. Once we've determined that the cylinder is the problem, how do we keep that problem from coming back? We're always interested in fixing things so that they stay fixed, right? And then we decide, do we repair the component or do we replace it? In a lot of cases, especially with pneumatic components, the cost of repairing it is more in time and money than the cost of a replacement component. So generally, replacement is our typical choice. And in a perfect world, that component would be readily available and it would be very simple. Once we've replaced the component, then we need to test, right? Make sure that we have solved the problem and that we haven't added any new problems. So if the component we replaced didn't fix it, we may have to look to see if there's a subsystem or an additional component that must be identified. And we also want to do a final check to make sure that we haven't introduced some additional problem, that in making a repair we haven't broken something else, right? And even if we didn't, we'll get the blame for it, right? And then finally, again, keep some records. Write this down. Get a maintenance record, write down the problem, the solution, what you found, notes as to the root cause, and any actions that have to be taken to prevent the problem from reoccurring. For example, the cylinder failed due to a rod seal leak and a worn rod bushing. The problem appears to be caused by misalignment. And recommendation would be to check alignment, install an alignment coupler, et cetera, et cetera. So even if we've gotten the machine running again, the final two things to do would be document what was done and schedule or make a plan for any repairs or improvements that would need to be made to keep that problem from coming back. All right, and so that's kind of the end of our troubleshooting section here. And This next section is just a bullet-pointed list of kinds of things that we might want to consider when we restart a large pneumatic system. Some of these things are compressor related and system related. So I'll just read through these or go through these, and then we can open it up for discussion. We'd want to check that cooling towers are operational, particularly in the case of water-cooled compressors, that we don't start up a compressor without making sure that its cooling system is working correctly and connections are tight. We'd want to check, before starting an air compressor, check that the inlet filter is clean and replace if necessary. Look down the throat of the compressor after the inlet filter. Make sure there's no debris or any water that might have been leaked in over time. I talked to one troubleshooter, one veteran troubleshooter, and he said they noticed just in the nick of time that there were about 10 gallons of water sitting in the throat between the inlet filter and the compressor inlet intake. And that would be disastrous, right? A compressor is meant for compressing air. Water doesn't compress. So drawing even a gallon of water into a compressor would have catastrophic effects. Check that there's no water in the oil on lubricated compressors. If the compressor is due for an oil change or soon to be, I would change it. If it's sat idle for a while, best to change the oil before starting up. You might note that as components cool down and then warm back up again, contraction and expansion could cause some issues. So a walk of the mainline piping, looking for oil or water or discoloration, and once pressure is restored, a check for leaks might be helpful. On older compressors, you may want to check the electrical insulation. Older units or larger units, it's possible that moisture may have collected inside the electrical motor. That might cause it to short circuit when restarted. So doing a quick inspection there might save you some trouble. We check the mainline filtration, make sure that the drains are operating, the automatic drains on the filters, the drain at the compressor, the drains on the dryers. This is a good time also to consult the maintenance records and look for the last filter change. If that's been a while, or if there aren't any records, this would be the opportunity to take those filter housings apart, check the filter for collapse, and replace if possible. Check the drains also on dryers and receiver tanks, make sure those are operating. The next recommendation is to operate compressors unloaded or very lightly loaded for half hour to an hour, especially in the case of larger machines. So close the valve after the receiver tank, let the compressor come up to pressure and unload, and let it run that way unloaded for a bit, and make sure everything comes up to good operating temperature. And then open the valve to the system, letting the compressor load gradually and not shock the piping system. Some other points, desiccant dryers may take some time to purge and become effective, so you may wish to leave a valve open after a desiccant dryer and let the dew point to establish to some acceptable level below ambient conditions so that you're not inadvertently sending some moisture downstream into your system. This is also a good time to verify that your dew point sensors are working correctly. And I would recommend that if you don't have an independent dew point sensor, put one in. Take this opportunity to do that, because the gauge on a dryer is not always accurate. There have been many cases where, the refrigerant dryer says that the dew point should be 38 degrees and the measured dew point is really 75. So those gauges tend to lie. So if you don't have an independent dew point sensor in your system somewhere after the drying equipment, it's a good opportunity to put one in. Then you know what's going on. Then as you start walking the plant, as pressure is, you'd first want to check the drain locations before repressurizing, like drip legs and other automatic drains or drain traps, so that if any moisture has collected during the shutdown, you can drain that away, and then walk the system again and repeat that process once you've repressurized the system to make sure that water, rust, and scale is drained away rather than moved downstream into your equipment. You do want to observe your safety protocols many facilities have rules against uncontrolled release of compressed air. So before just cracking open a valve on a drain, you may need to fit a silencer or some other device, coalescing filter or something to contain that compressed air and contain any debris or particles that might escape if you just crack open a valve somewhere. It also would be good practice to close lockout tagout valves before repressurizing. And that's also an opportunity to confirm that your safety equipment's in place and functioning properly. You also may wish to vent compressed air lines before you open the lockout tagout and restore pressure to the machine. And again, observe the protocols there for uncontrolled release of compressed air. You may need to take some steps to do that safely. All point of use filters should be checked once before pressure is restored, and again before, if moisture starts to collect. You want to confirm that automatic drains are working and that no drain mechanisms are stuck. Keep replacement filter elements on hand. There's a chance that as you restart, that debris has come loose inside your piping system and will end up in the machine filters. And if you really don't know when the last time the filter element has been changed, this would be a good opportunity to change them before startup. So those are kind of the basics here. Let's check if there are any questions. Do we have any, Brad, and any comments, heresies?
Unmuted.
Okay. It looks like you have one question. Is there a way to get a copy of this webinar?
Oh, well, that's an easy one. We have recorded this, I believe, and
Yes, we have.
And we'll make this available after the fact. We can also make the slideshow available if anyone would like to present it themselves. That's not a problem. But I believe these are going to be stored on a YouTube channel so that they can be accessed by customers as well. Is that correct?
Yeah, we'll put this on a YouTube channel called Powered by SMC.
Excellent. Okay, so that answers that question. Is there any other questions? Anyone want to type something in last minute? If not, I thank you all for your kind attention, and certainly don't hesitate to contact SMC if you need anything else.
Somebody asked, is there a way to get a list of people in attendance? And I really, for privacy concerns, I would recommend not doing that, but unless you have a specific reason. But I would recommend not doing that, but we can obtain a list. So
yeah, I guess contact us offline if you have a need to know if anyone specifically was was listening in, right?
Yeah. I wouldn't want to give the entire list, but he said he was just looking for attendance for his company.
Yeah, check with us offline if you have a specific name we can see, right?
Here, I'm going to answer you. Let's see.
Oh, okay. Yeah, or just checking to see if a customer is in attendance. Okay.
Yep.
Okay. Anyone else? Anything? If not, then thank you, and all have a good afternoon. Do we need to do anything else here?
No, we're done. Thank you.
Do have
I
to-
just need to end it.
Okay. All right. I'll stop showing my screen.
Yep.
And I'll sign off.
And then I'll record. I've got the recording. I'll let you know where that is.
Okay, that'd be great. All righty.
Thanks, John.
Thank you very much.
Good job.